Hi, my name is Mark, and I'll be presenting the effects of tip injection on the performance and near wake characteristics of a model wind turbine rotor. Pressure difference between the upper and lower surfaces of a wind turbine blade results in flow leakages along these surfaces. This is shown in Figure A. When the leakage flow meets the main flow stream, vortices are created which can cause performance losses for individual turbine systems. Additionally, further structural and performance problems in arranged wind turbine farms occurs due to vortex turbine interactions in succeeding turbine systems. Previous studies have shown that tip injection is able to mitigate this effect. This paper presented an experimental investigation into this topic. The experiments were conducted in an open jet wind tunnel which aimed to replicate real-life wind conditions experienced by wind turbines. A model wind turbine was used which was prototyped for real-life systems. This can be seen in Figure 1A. The model was specifically designed to allow pressurized air to pass through and be injected from the tips while the rotor is rotating, which can be seen in Figure 1B. Measurements were taken for different tip speed ratios at various locations. The measurement locations where the upstream and downstream measurements and wake area traverses were taken is shown in Figure 2. Effects on power and thrust. Figure 3 presents the measured power and thrust coefficient variations for the baseline when no injection occurs and injection cases. The solid black line represents the baseline and the corresponding symbols represent the different injection rates. For a tip speed ratio less than 3.5, there is minimal effect due to tip injection. Greater than 3.5, observable effects are seen. As a result, this experiment would indicate that greater tip injection increases the amount of power and thrust within the turbine rotor, which would lead to better performance. Effects on tip injection on the flow near the rotor. Figure 5 shows the inflow speed just upstream of the rotor and estimated angle of attack for the baseline and injection case. This is shown for a tip speed ratio of 2 and 5 over the span of the blade, which is represented by Y on R. A general increase in inflow velocity is seen, which corresponds to a greater angle of attack when injection occurs. Lower tip speed ratios yield greater effects. An increase in inflow velocity will lead to an increase in performance as more power is able to be generated. Figure 6 shows the axial velocity and turbulence intensity variations just downstream of the rotor. Near the blade tip region there is a sharp increase in velocity and turbulence intensity for the injection case. This indicates further effects are created due to tip injection. Effects of tip injection on the wake. Figure 7 shows the velocity distribution within the wake of the turbine at varying distances from the rotor. It can be seen in the right column, where tip injection is included, that there is an increase in size of the low velocity region. The contour lines also become less packed as the flow moves downstream. This indicates tip injection changes the characteristics of the wake. The actual impact is more evidently displayed by the turbulence intensity, shown in Figure 8. It can be seen in the right column, where tip injection is included, that the vortices are pushed radially outward. This region is now marked with higher turbulence levels and becomes more packed with contour lines. This region becomes quickly enlarged downstream, indicating diffusion of the vortices. This is important for turbine arrays, as it means downstream turbines will be exposed to less concentrated vortices. As a result, tip injection can provide several benefits for horizontal axis turbines. It can improve the power and thrust of a turbine rotor and increase inflow velocity, leading to increased performance. Furthermore, it can impact the characteristics of the wake by reducing the intensity of vortices downstream. This reduces the exposure of downstream turbines in turbine arrays to concentrated vortices, which can cause structural and performance problems. Thank you.